In this class, now I am going to explain you two problems from partial fractions. So the two problems are based on power series expansions. So before going to learn the two applications, now I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Now let us see that power series expansion formulas. If you know that power series expansion formulas, so then we can able to tackle that two applications. Right. Now let us see 1 minus x minus whole power minus 1. Here minus in the power plus minus is given, whose expansion will be like this: 1 plus x square plus x cube and so on plus x power n and so on. Suppose here, suppose plus there minus is given. Now whose expansion will be alternatively here plus minus and so on. 1 minus x plus x square minus x cube and so on plus minus 1 whole power n x power n and so on will come. See here students, next 1 minus x whole power, suppose minus 2 is given, then whose expansion will be like this: 1 plus 2x plus 3x square plus 4x cube and so on n plus 1 into x power n plus and so on. So suppose here plus there minus is given in the exponential place, whose expansion will be like this: alternatively plus minus 1 minus 2x plus 3x square minus 4x cube and so on plus minus 1 whole power n into n plus 1 x power n plus and so on. But all in all these expansions, so condition for x is minus 1 to 1, mod x less than 1, mod x less than 1, which means that x value will lie between minus 1 to 1. Mod x less than 1, which means that x value should be minus 1 to 1. You know this. Okay. So I solve this modulus inequation. If you want, I can explain you how the solution of this inequation is minus 1 less than x less than 1. Let us see this solution set. Right. See students, mod x less than 1. Now square on both sides. If you take square on both sides, you know mod x square can be written as x square. So square on both sides. Now x square less than 1. Now bring this one to the left side. X square minus 1 less than 0. See. Now factorize it. X plus 1, x minus 1 less than 0. Now equate these two linear factors is equal to 0. On equating these two is equal to 0, we will get x equal to minus 1, x equal to 1. Now go to the number line. Now represent both of them on the number line. Here we will get minus 1, here we will get plus 1. Now see here, apply the wavy curve concept. Here plus minus plus. We require the solution set for x in such a way that that must be less than 1. Means here we have to consider this interval for x. So our required interval for x is minus 1 to 1. Okay. I hope you have understood this 4 expansions. One is 1 plus x whole power minus 1 and 1 minus x whole power minus 1, 1 minus x whole power minus 2, 1 plus x whole power minus 2. So if you know that 4 expansion formulas, then we can answer to these two questions. Let us see these two problems. Find the coefficient of x power 4. Find the coefficient of x power 4, coefficient of x power 4 in the power series expansion, power series expansion of 3x by x minus 2 x plus 1. This is the question. Find the coefficient of x power 4 in the power series expansion of this, specifying the interval in which expansion is valid. Means here mod x must be less than 1. You know, when those 4 expansions will be valid, whenever x value must be minus 1 to 1. Here the condition for x is mod x less than 1. I hope you have understood this question. Find the coefficient of x power 4 in the power series expansion of this rational fraction. How do you find that power series, coefficient of x power 4 in this? First we have to express this rational fraction as partial fractions. Now resolve into partial fractions. See, observe the denominator which contains non-repeated linear factors. Now 3x by x minus 2 x plus 1. Now which is equivalent to a by x minus 2 plus b by x plus 1. b by x plus 1. a by x minus 2 plus b by x minus 1. Okay, you know, whenever the rational fraction contains non-repeated linear factors in the denominator, so in such case we would have to resolve whose partial fractions like this, a by x minus 2 plus b by x plus 1. Now take cross multiplication. Now 3x by x minus 2 x plus 1. Now when you take cross multiplication, a of x plus 1 plus b of x minus 2 whole by x minus 2 x plus 1. Now cancel these two. Now evaluate this a and b values. So put x equal to 2. If you write x equal to 2, then you can make this term will become 0. If it is 0, then you will get a value. Now put wherever x is there, there you write 2. 3 2s are 6 here. When you write x equal to 2, 2 plus 1, 3. 3a. When you write 2 here, 2 minus 2, 0. Now your a value will be 3 1s are 3 2s are. A value is 2. Now next put x equal to minus 1. When you write x equal to minus 1, it is going to be minus 3 and this part will become 0, minus 1 plus 1. So that here what do you get? B of minus 1 minus 2. So here minus 3 cancel, your b value will be 1. You got a value as 2. 2 by x minus 2 and plus b value 1. 1 by x plus 1. Okay, now we got whose partial fractions. Now expand these two partial fractions. How do we expand? See students, 2 by, so x minus 2, I would like to take minus 2 common from the denominator. When you take minus 2 common, so here inside 1 minus x by 2 you will get. See, minus 2 if you send inside, minus 2 into 1, minus 2, sorry here, minus 2 into 1. So here plus 2 we would have to take comma, or minus 2 only. Minus 2 only, minus 2 into 1, minus 2, this minus into minus plus, 2 cancel, x you will get. I hope you have understood this. Now in the next step, here x plus 1 is given, but write here 1 plus x. Now this 2 cancel. So here minus of, when you take this one into the numerator, you will get 1 minus x by 2 whole power minus 1. So here it can be written 1 plus x whole power minus 1. Now apply the power series expansion formulas for these two. You know whose expansion? Here minus is given. So in such case all terms will be positive. So 1 plus x by 2 plus x square by 4 plus x cube by what do we get? 2 cube 8. Now x power 4 by, so 2 power 4 16 you will get, and so on. Here itself you people have to stop whose expansion, because in this problem we are finding coefficient of x power 4, so that we got coefficient of x power 4 from this term, because in this term there is x power 4, hence here itself you have to stop this expansion. No need to write remaining terms. Now go to this one. Here also write whose expansion. Here plus, here minus is there. Alternatively plus minus will come. 1 minus x plus x square minus x cube plus x power 4 and so on. Now what is our aim? We would have to collect the coefficient of x power 4 in these two expansions. So here how much do you get x power 4? Coefficient 1 by 16, but before that minus is there. So minus 1 by 16 and go there, x power 4 coefficient plus 1. So this is our required answer to this question. Coefficient of x power 4 in the power series expansion of given rational fraction. If you want, you can simplify this. On simplifying this, you will get 15 by 16. 15 by 16 is our required coefficient of x power 4 in the power series expansion of given rational fraction. Right. Now let us go to learn one more application. See that same like this question only, but in that we would have to find coefficient of x power n. Find the coefficient of x power n in the power series expansion of x by x minus 1 whole square x minus 2. This is the question. Okay students, what you would have to find here? Coefficient of x power n in the power series expansion of this rational fraction. So what is our primary duty? Here we would have to resolve this rational fraction into partial fractions. How do we resolve? See here, x by x minus 1 whole square and x minus 2. So here denominator contains non-repeated linear factor and repeated linear factor. In this type of applications, we have to resolve into the rational partial fractions. Here whichever one is repeating, that should be written like this. Here a by x minus 1, b by x minus 1 whole square plus here c by non-repeated linear factor x minus 2. Okay. Now find ABC. See the denominator and write whose partial fractions. Now evaluate ABC. How do you evaluate this ABC? X minus 1 whole square and x minus 2. So which is equivalent to what is LCM for RHS? X minus 1 whole square and x minus 2. Now here what do we get? A of x minus 1 plus, tell me students, here a of x minus 1 and x minus 2 also you will get here. You know, now come here. Here what do we get? B of x minus 1, B of x minus 2, sorry, here B of x minus 2 and plus C of x minus 1 whole square. Okay, multiply these three fractions with this LCM, so that here you will get this one and here x minus 2, there x minus 1 whole square. Okay students, now evaluate that ABC. So in the denominator we can cancel it. See here, how do we evaluate this? Put x equal to 1 on both sides. Put x equal to 1 on both sides. Here if you write 1, here it is going to be 1 and this part becomes 0, 1 minus 1 0 and here 1 minus 1 0. Here b of minus 1 you will get. Now simplify. Your B value will be minus 1. B value you got. Now think for A and C. Okay. So for okay, A and C. Now I would like to compare. See here, x is equivalent to. So when you take whose cross multiplication, here inside. Otherwise do one thing. Put x equal to 2 on both sides. Here we kept x equal to 1. On keeping x equal to 1, we have evaluated B value. So if you put x equal to 2 here, x equal to 2, this part becomes 0, this part becomes 0. Here left side, it becomes 2. RHS 2 minus 1, 1 square value 1. Now C value is 2. Now B you got, C you got. Now think for A. So for A, what do? Compare coefficient of x square on both sides. So here there is no x square. So that here you will get 0. And here coefficient of x square will be A only you will get. X into x square no. Before that A is there. So that you will get A. Now here A minus B whole square. So x square whose coefficient will be plus C. Now your A value is, so C value already we prepared. Right here if you write a C2, then your A value will become, A value is equal to minus 2. A you got, B you got, C you got. Now replace this A, B, C by that A, B, C here. I hope you have understood till here. Now here after see here. A value how much? Minus 2. Minus 2 by x minus 1. B value is minus 1. Minus 1 by x minus 1 whole square. And C value is 2. 2 by x minus 2. Now in this what we would have to find? Coefficient of x power n in the power series expansion of these three partial fractions. Now, okay, so convert this 3 into the power series. How do we convert? So here you would have to take minus common. When you take minus common here, minus 2 by minus of 1 minus x. And here also take minus common. But here whole square is there. While taking minus, so minus power even becomes positive. So that it can be written minus 1 by 1 minus x whole square. When you take minus common from the denominator, your sign will not change. Because students, whole square is there. So that it becomes positive. Here minus only will come. Here when you take minus common, so here minus 2 by 2 of, tell me students, 1 minus x by 2 you will get. Okay? Right. Now in the next step, see here. In the next step, minus minus cancel. Now it can be written 2 into 1 minus x whole power minus 1. And here it is minus of 1 minus x whole power minus 2. Okay students. Right. Here 2 cancel. Minus of 1 minus x by 2 whole power minus 1. Okay students. Right. Now apply that expansion formulas for these three expansions. So here, what do we get? 1 plus x square and so on, x power n and so on. So here 1 plus, here minus means entire series will be positive. 1 plus 2x plus 3x square and so on, n into n plus 1, x power n and so on. And what about this? Minus of 1 plus x by 2 plus x square by 4 and so on, x by 2 whole power n and so on. Now here what we people require students? Coefficient of x power n. Now here in the first series coefficient of x power n is 1, but before that 2 is there. So coefficient of x power n, required coefficient, right here, required coefficient of x power n, required coefficient of x power n is how much? So your x power n coefficient is 1, 1 into 2, 2. Now go there, x power n coefficient, before that minus is there. Minus of n into n plus 1. So your x power n coefficient 1 by 2 power n, before that minus is there. Minus 1 by 2 power n. So here itself you can stop. Okay, this is our required coefficient of x power n in the given rational fraction expansion. Thank you, students.